behalf of the American Geographical Society, I'd like to welcome you to the first installment of Geography 2050, The Future of the World Ocean. The dialogue continues. Last November, we gathered at our annual symposium to analyze the vital trends reshaping our oceans. One of the themes we covered was oceans as a contested environment, where we convened leaders in national security and geospatial intelligence. Since the symposium, our concern for the ocean has expanded. Increased maritime conflict, worsening climate change, continued immigration, new questions of territorial sovereignty, and a host of other issues are focused on our oceans. And at the center of it all is how to better understand these forces so we can address the pertinent issues quickly and efficiently. From our perspective, we are especially optimistic that by utilizing sensor and satellite technology, we will be better equipped than ever before to ensure the oceans as a safe and usable environment for everyone. Thanks for joining us today as we continue to look towards the future of the world ocean. It is a pleasure for me to turn this discussion over to Dr. Christopher Tucker, the chairman of the American Geographical Society. Chris?
For millennia, oceans have served as a world stage on which empires, nations, and non-state actors have projected power. Commercial maritime fleets, navies, privateers, pirates, criminal traffickers, and everyday watermen have all taken to the seas, where it has always been a challenge to differentiate between friend and foe. Moreover, as humanity has grown its presence in and around our seas, our national security enterprise has increasingly been challenged to provide both search and rescue services and humanitarian disaster response that requires unprecedented understanding of this vast, complex, and ever-changing marine environment. After all, our oceans cover more than 70% of our planet, a space larger than even the biggest empires have conquered on land. Maritime domain awareness is the term often used to describe the goal of our joint forces as they grapple with assembling their collective understanding of what is going on within our oceans. Intelligence, surveillance, and reconnaissance, or ISR resources of all kinds, are brought into service to collect many different kinds of observations based on the technical capabilities of each ISR platform and sensor. Then this deluge of observations is harnessed by geospatial intelligence, or GEOINT analysts, to create a rigorous spatio-temporal understanding of the activities observed in and around our oceans to help reduce uncertainty about what is going on in our oceans and to piece together these observations to provide decision makers with a superior understanding of their operational environment. Whether we are grappling with piracy or near-peer naval threats, law of the sea territorial disputes or drug interdiction, humanitarian assistance, disaster response, or search and rescue, we must first achieve maritime domain awareness, and the increasing number of remote sensing satellites promise a future where we are better equipped to undertake all these missions. Today's webisode on ocean ISR and GEOINT will focus on the many forms of satellite remote sensing that are available to national security decision makers and how they can best be used to provide a comprehensive understanding of our oceans. The future of satellite remote sensing looks bright. The commercial remote sensing industry is receiving unprecedented levels of investment, helping innovators bring new technologies to orbit at an astonishing rate. Governments, too, are continuously investing in new space-based capabilities for observing our planet. What this means for our understanding of the oceans, particularly in terms of our national security enterprise's ability to make sense of threats, cannot be understated. No single satellite can observe the entire ocean, and no single kind of satellite can see all that needs to be seen at a particular moment in time. Today's webisode will bring together experts in various forms of satellite remote sensing to discuss how space-based Earth observation has evolved to help us make sense of our oceans and how it will help us tackle the complex maritime security challenges that our increasingly crowded planet poses to our global society.
As our oceans get more crowded, it becomes more difficult to differentiate friend from foe. The many new remote sensing options available to the national security enterprise give us more tools for sifting through the proverbial haystack. None of them will be a silver bullet, but together they help us make sense of the threats we face upon the high seas, in our harbors, and within our highly trafficked waterways. The intelligence process seeks to reduce the uncertainty that decision makers face. It demands that we harness multiple sources of information that can help us triangulate on and chip away at those uncertainties. Now, with so many commercial remote sensing options, each with their own phenomenologies, revisit rates, and other unique characteristics, intelligence professionals have more resources than ever before within which they can make sense of our vast and ever-changing maritime environment.
Today, we will begin our exploration of the power of space-based remote sensing with a focus on electro-optical, or EO imagery. We've been taking EO pictures of our planet for decades. Maxar, formerly Digital Globe, has been a leader in collecting space-based EO to help us understand our oceans and the rest of our planet since 2001. Mr. Brian Smith, Director of Maritime Product Management at Maxar, will help us understand how EO helps us secure our oceans.
I'm Brian Smith. I'm a Director of Product Management responsible for maritime products at Maxar Technologies. And today I'm going to give a little talk around what we're doing to identify illicit maritime activity remotely. As you all know, the oceans are vast, vessels move, often operate dark, making it difficult for navies, coast guards, and other maritime enforcement agencies to deploy resources effectively. And if you think about it, across use cases, whether it's sovereignty protection, fisheries protection, or any number of counter-trafficking type use cases, having a comprehensive understanding of vessel activity is key to make sure that you're deploying resources successfully. Today, the most common commercial data set for maritime situational awareness is AIS. AIS is great in the sense that over 200,000 vessels are reporting on a daily basis, and it's a near real-time feed. However, it also has its shortcomings. It's not required for vessels of all sizes, only for vessels greater than 300 tons. It's easily spoofed, easily turned off, and doesn't work well in heavily trafficked areas. And as a result of all that, if you're a vessel that's engaged in illicit activity, you're likely not broadcasting your location accurately. So we at Maxar Technologies are bringing our leading Earth observation constellation to this problem set. So just to take a little step back, Maxar Technologies is a leading space provider, a space solution provider. Two main businesses. We've got a space infrastructure business where we manufacture satellites, robotic arms, things like that. I'm not going to focus there. The other business we have is something we call Earth Intelligence, where we leverage our optical constellation, industry leading from a resolution perspective, accuracy perspective, to solve customer problems. We provide imagery, we provide analytics based off of that imagery using AI, ML-based workflows. We bundle that with services, and we have a services branch that utilizes this and a variety of other GeoLink data sets to provide customers with insights. So the way that we're doing this and leveraging our assets is we're taking multiple sources. So our industry-leading optical imagery, commercial SATSAR, AIS, and other data sets, things like emerging RF data sets and other customer data sets. We're marrying that with innovative processes, things like AI, ML-based vessel detection, AIS correlation, and new automated tipping and queuing capability, which I'm going to talk about later, which is really key for bringing optical to bear in the maritime space. Low latency alerting, so that these insights are actionable and you can actually use them to deploy resources effectively, and also mission relevant analysis. And all of these bundled together allow navies, coast guards, other maritime security agencies to use this information for actionable intelligence, to deploy resources to the areas that matter most. In this example, an illustration where we're capturing oil transfer in violation of sanctions. So how are we doing that? We're doing that through our Crow's Nest Maritime Monitoring and Security solution, which provides comprehensive satellite surveillance. That solution today consists of 4 primary products. So first, multi-sensor SAR vessel detection service. Commercial SATSAR is great for covering broad areas, detecting where there's vessels. Our multi-source solution allows for us to really customize revisit and coverage to match our client's operational tempo. And while that's fantastic for detecting vessels, it does leave something to be desired in actually identifying vessels and identifying vessel activity. As a result of that, we combine that with our maritime tipping and queuing offer, which provides greater insights into the vessels that matter most. With our optical imagery, you can actually see what's going on the ocean surface, illuminate dark targets, and identify vessels, identify vessel activity, and therefore make informed decisions, deploying resources with confidence. We also have optical and SAR port monitoring, where we'll create kind of revisit schedules, customized monitoring plans, where we'll start with a baseline of activity, and then as new collects come in, update our analysis. And we have an application in development to allow for easy analysis of all these data sets. We bundle this with expert analysis to provide insights with our seasoned kind of analyst team. And for the remainder of the conversation, I'm going to focus on two of these products, our multi-sensor SAR vessel detection offering, and then our maritime tipping and queuing offering. So first on the multi-sensor SAR vessel detection offering, I wanted to give you just one example of why this is powerful. What we have here depicted on the map are multi-sensor SAR vessel detections that we've correlated to AIS. Black icons are those we were unable to correlate to AIS, so they're vessels that are operating dark, while white and green icons are those we were able to correlate to AIS. And as you can see on the screen, there's a lot of black icons, meaning there's a lot of vessels that aren't reporting, and if you're relying upon that as your primary source of vessel activity and information, you've major gaps in your knowledge. And on the headline, you see anywhere from 30 to 90% of vessel traffic is dark. And I know that's a wide range, but that's what we see across geographies. There's certain areas where most traffic is dark, but even in areas where a lot of vessels are reporting, there's a number of vessels that are generally operating dark. Now, while commercial SATSAR and vessel detection is great for detecting vessels, covering broad areas, and with our multi-source kind of approach, we have the ability to truly customize the offering to match operational needs. There's information that's lacking from a SAR kind of image of a vessel. So we have one of those here at right from a kind of broad area coverage mode. And with it, you can't tell what vessel type this is, the vessel class. Certainly can't tell any sort of activity the vessel's engaged in. You can't use this to identify a vessel. And really, that's where the power of optical comes in, as you can see from this illustration. So on the left, we have a little SAR image where you can see a likely transshipment event occurring. And we utilize that to tip our optical satellites and gather this image where you can clearly see transshipment in process. You can see ship-to-ship oil transfer. And where you can utilize this imagery to actually identify the vessels engaged in it. In this case, it was the Adrian Daria 1 and the Jasmine oil tankers. And this transshipment was occurring off the coast of Syria in violation of sanctions. So just one kind of example of how this is relevant. Now, at the time that we did this example, this is a very manual process. It was something that we were really utilizing to demonstrate the capability, but not something that we were ready or able to scale and provide to customers. Since then, though, we've invested heavily. And at this point, we have an automated tipping and queuing capability, a maritime tipping and queuing product that seamlessly captures images of vessels of interest. So the way it works is based off of metadata within AIS, based off of metadata within SAR vessel detections, or even from alerts from other systems. We can automatically task our satellite constellation, process the imagery, run AI/ML-based vessel detection, run AIS correlation on that output, and then deliver the image chips along with the correlation in kind of either email alerts or in other kind of alerts in low latency. So just to give you some examples, say from AIS, you're interested in tracking illegal fishing, and you're interested in certain reefer vessels engaged in transshipment that may be broadcasting. You could task whenever those MIMSs are in a certain location or maybe starting to move slowly, indicative of potentially being involved in transshipment behavior. And our constellation will estimate the future location of those vessels that are next available pass, do the collection, do the processing, run AI/ML workflows, and detect vessels within it. Within SAR, vessel detections, commercial SATSAR, similar process, less metadata to work from, but just have size of vessel, beam of vessel, or length and beam of vessel, and also location of vessel, which we can tip off. So next, I'm going to give you a few examples of this in action. First is a IUU example where we were tracking a fishing fleet in the Eastern Pacific. In this instance, we tasked off of AIS from the reefer vessels shown here. These vessels were transponding via AIS. However, there were a number of vessels around them that were operating dark and that we had captured previously fishing within the EEZ. The reefers were just outside the EEZ. We triggered the collection because they began moving slowly. And with that, we were able to capture these vessels that had been operating dark within the EEZ, fishing where they should not have been fishing, popping out, offloading their catch, masking that illicit activity by transshipping to the reefer vessels that were in a legal area. And with this, with just the fidelity of the image we have here, you can actually see the refrigerated cargo holds open, showing that transshipping is occurring. Next example I have, I'm sticking with our fishing theme. So what you can see here is just the ability to easily identify fishing activity from space with our high resolution optical satellites. First example, you have purse seine fishing, where you can very easily see the net surrounding and going around the vessel. Those swirls next to the vessel too are actually support craft as well, which if I zoomed in, you could see those. Middle example shows another fishing vessel. And by the image, you can tell now that there's an absence of a wake, meaning that it's not moving, which could be interesting. Could be that it's about to be engaged in transshipping or some other sort of activity. Last example we have here is another fishing vessel where you can see the line coming off the vessel and into the water. So just another example of being able to see activity from space. Shifting gears a bit, show an example here for a large kind of container vessel, shipping vessel. And what you can see from this high off nadir shot is that you can identify lettering on the side of the vessel. You can identify the flag on the vessel and use this to positively ID the vessel, which is powerful, particularly if it's operating dark. And it's one of the main value props that we're sharing with the market. And one of the reasons why we're getting a lot of initial traction. Last example I have here is a vessel we were tracking at a certain location in October. A few days later, so we initially captured an image of the vessel on the left. A few days later, captured an image of a vessel that was very similar on the right. Initially, we thought it was the same. But detailed analysis showed that while there was similar vessel shape and draft, similar lifeboat arrangements, there were dissimilar deck structures. It actually wasn't the same vessel, but it was the same vessel class. So again, just one example showing you the power of utilizing satellite optical imagery for identifying dark vessels. Now, with this automated capability, we're able to do this at a global scale. Give you context of what you're looking at. We have a map with orange depicting our last 30 days of collections. Previously, you would have just seen orange over landmass because that's really the only areas that we were collecting, because that's the only areas where we were getting something useful. We weren't getting a lot of value in just tasking the oceans without directing in a vessel, so we weren't doing it. With this automated capability, with the ability to actually capture vessels of interest, we're now tasking over the oceans at a global scale and generating useful information for our customers. And in the future, the near future, we have a new constellation coming online. Back half of this year, we have 2 of those satellites being launched, with another 4 coming the following year. And with that constellation, we'll be tripling our 30 centimeter collection capacity, so our industry leading resolution, and also enabling intraday revisit of up to 15 times per day. And in my eyes, that's a game changer in the maritime space. It gives you just that many more opportunities throughout the day to tip and to get that optical confirmation of what's going on the ocean's surface, to get more opportunities to capture illicit activity. We're really excited about the new constellation coming online and excited to deploy it for our maritime missions. And a lot of what I've talked about today, I've stuck with more kind of commercial use cases, things like IUU, fishing, sanctions evasion. But a lot of what you're hearing, I'm sure you can think of relevant kind of more defense and intelligence use cases as well, because a lot of the same processes can be utilized for defense missions. So with that, if you have any questions after the fact or want to provide feedback, please feel free to reach out. Thank you very much. Appreciate your time and attention.
So what happens when we become capable of imaging the entirety of our oceans once a day? Only a few years ago, this became possible when Planet Labs put more than 150 small sats on orbit, operating as a sort of line scanner for our planet. What this high cadence of revisit means for our ability to understand our fast-changing oceans is something Ms. Jen Marcus, Vice President of U.S. Government Strategic Engagements for Planet Federal, will help us understand today.
Well, thank you. I'm Jen Marcus. I'm with Planet Federal, and I am so excited to be here today. Thanks for having me. I'm going to jump right in to talk about Planet's small satellite constellations and a little bit about what we do collecting imagery over the oceans. So if you don't know Planet Labs was founded with a mission. We call it Mission 1, and that was to image the whole world every day. Mission 1 has been accomplished. We needed about 110 small satellites to be able to get an image of everywhere in the world every day. Our Mission 2 is to make that change visible, accessible, and actionable. It's visible now, and we're working on the analytics to make it accessible and actionable. We actually have two types of constellation in orbit now. We have our Dove satellites, and those are the ones that do orbit Earth every single day. We have about 180 of them that are operational. So we have beyond the number we need to get an image everywhere, every day. And the telescope on those is referred to as PlanetScope. So sometimes you hear them referred to as Doves, sometimes PlanetScope, and PlanetScope is actually the imagery that we collect off of them. We also have 21 SkySat satellites. We acquired those from, it was actually a company called Skybox that Google had acquired, and we acquired the SkySats from Google. We have 21 of them, and they are more traditional satellites. They're still small. They're about the size of a dorm fridge or a dishwasher. And they also orbit, but they're taskable. So those are more traditional satellites because they are taskable. They can point and take a picture, and they collect at about 50 centimeters resolution, whereas our Dove satellites collect at about 3 meters resolution. Planet, in the development of the company to reach Mission 1, we adopted what we call Agile Aerospace. We adopted an Agile approach that's used in software development to the development of satellites. And what that's allowed us to do is have 15 different builds of those Dove satellites over the last 7 years. We continuously iterate on investments that are made across the hardware industry for batteries, for cameras, for all kinds of electrical components that are basically we can buy off the shelf. And what we've done is integrate those into satellites that are about the size of a loaf of bread. When the solar panels are folded around, when they flap out, it's a little bit bigger. But it's an amazing process, and they are manufactured right in downtown San Francisco. We can manufacture about 30 of them a week if ever needed. And I'm going to do a little video in video. I hope this works okay. So obviously this is, for all the geographers out there, our Earth that is orbiting around, and the Dove satellites, they are always on. And they're basically like a string of pearls that just orbit. And as the Earth rotates, they're collecting images. They're always on collecting images. Then our SkySats, like I said earlier, there are 21 of those. The first 15 are in a sun-synchronous orbit at 98-degree inclination. And the SkySat 16 to 21 are in a 53-degree inclined orbit. So we get 2 different passing times a day with the SkySats. Depending on where you want to look in the world with a SkySat, we can collect up to 10 images per day of that same location. So the motivation for really the founding of the company was that we need to monitor everywhere, every day, so that you can see everything, especially things that are related to climate change and environmental change in our world. As long as you can see things, then you can analyze and make decisions and make changes. We've applied our daily revisit to open oceans. We spent some time working with the Navy SPAWAR on improving our rectification off of our Dove satellites so that we could orthorectify imagery over the open ocean. So we do have a product that can collect that imagery. And what you're seeing here is, because we're collecting every single day, we see things that we didn't know would be there, because you don't have to know where you want to look. And one of the most interesting things that we've caught with that everywhere, every day capability is this Chinese naval exercise that was happening in the South China Sea. Experts who study the Chinese military were very interested in this because they knew there was going to be an exercise. What they didn't know was that aircraft carrier, the bigger white dash looking thing in the ocean, would join that fleet of about 40 submarines and other ships. So this was for analysts who are looking, they want to see our data in that open ocean every day. And they were able to tell that the Chinese were making a global statement about their strength for what we saw in this exercise. Some other interesting things that we've applied for maritime awareness is we can see the collection of vessels in this disputed reef in the South China Sea. So you can see one day in September 2020, there's not much going on in that middle part of that reef. And then you see in the right-hand side, some kind of copper looking things. So what we did was we saw those in our daily collection from PlanetScope, and then we sent a tip to our SkySat capabilities to actually take a higher resolution image of that area. It took me a while in looking at this to realize what this is. It looks like stacks of pennies to me, but those are actually ships that are lined up together. And they're in an area where they weren't supposed to be. This was an international sort of dispute that just happened recently in March of 2021. So that sort of shows how the capability of the everywhere, every day can work hand in hand with a traditional tasking method from our higher resolution satellites. This is another one that's actually a sad story. But disaster monitoring, so maritime disaster monitoring. This is a port in Mauritius where a ship was headed towards the land. There's one of the largest coral reefs is in this area. Apparently, the Coast Guard or whatever they're called in Mauritius was letting the ship know that it needed to turn. It shouldn't be coming this direction, and it continued and ran aground. And then over a couple of days, as they were trying to get it out of there, it filled up with so much water that the ship actually broke in half and then started to, disintegrate in the ocean. And it was one of the largest oil spills. It was an oil ship, one of the largest oil spills that there has been, and has caused great damage to that coral reef. But the ability to be monitoring and see what's happening, we're able to catch images to provide to both analysts, to disaster recovery people, that just wasn't possible before Planet existed. Another example, again, a Chinese example of being able to see progress on development of aircraft carriers. So you can see this one. This was one of the bipartisan think tanks in the DC area who studies the Chinese military, uses our imagery. They look every day to try to see what's happening and what they can infer from the building that they're seeing from the imagery. And this next slide I think is really interesting. So they're able to even analyze the size of what they're seeing built to determine what type of carrier that is. and what that means for what the Chinese military is preparing for. And the last one I'll show you is about tracking illicit trade. So this is an image that was actually part of a larger New York Times story. So the sound is removed from it. But what's very, very interesting is, again, collecting everywhere, every day. A lot of places in the world are covered in clouds. Some of our users ask us to still see all the imagery, even if there are clouds, because they are looking for things that they know where they want to be looking and they know what they're looking for. So even imagery with clouds in it is helpful to them. And if you look at this, again, the sound is removed here. This is the cloudy image. One of us who's not an expert or imagery analyst in this area wouldn't know what to look for, but down in the corner here, they can actually spot a ship, an oil ship doing a transfer in the water there. And I believe that's the ship in port. So having imagery everywhere, every day that we can publish, even with high levels of clouds, has been useful for our user community. Oops. Let's see if we can move off of that. There we go. So I could talk all day about the capabilities this company has developed. I'm still in awe of the innovation of Planet Labs, the development of satellites in San Francisco that are launched into orbit. We really have a massive data center in space that's providing images of everywhere on Earth's landmass and in the oceans on a daily basis. And the potential for what can be derived from those data sets is endless. Thank you for having me to talk today about how we use that information over our oceans.
When focused specifically on the tracking of ship movements, we have come to rely on the Automatic Identification System, or AIS, an automatic tracking system that uses transceivers on ships. The early terrestrial AIS from the 1990s finally made it into space by 2005, giving it global reach. The father of AIS, Mr. Guy Thomas, Managing Director of C Sigma LLC, will help us understand how AIS helps us secure our oceans.
Hi, my name is Guy Thomas. I've been working in the maritime domain since 1958 when I was a Sea Scout. I've been working in surveillance systems since 1968 when I was a young intelligence officer. I spent 23 years in the Navy, qualified in all four venues, surface, subsurface, air, and space. In 2003, I became the science advisor for maritime domain awareness for the United States and invented satellite AIS. I had the concept 2 years before that, but I finally got money in 2004. When we built that, had many different people come and talk to me about that, and obvious by late 2005, early 2006, that obvious the answer to maritime domain awareness, maritime security, and safety at sea was space. And I'm going to talk about that today. We came up with the concept collaboration in space for international global maritime awareness. It's called C Sigma. When I originally wrote it, security was first over here. But in fact, it's also really important for maritime environment and protection of its resources and maritime safety. Civilian space has had a tidal wave of capability happen to it in the last 10, 12 years. It's been led by satellite AIS. We need to build a global space partnership across the world. This brief is an extraction. It's 10 slides out of 70 on the implications of global maritime awareness and how trends in commercial space and the data environment are going to allow us to build the global maritime awareness system. By the end of the 20th century, we all knew it was an interconnected world, but most of us, unless you were directly involved in the commercial maritime world, really didn't understand that in the maritime domain, things were not as connected as they could be. However, in 2008, with the launch of satellite AIS, that changed all that. They gave us a common frame of reference. And there are many companies now making a lot of money on satellite AIS. It has provided the needed locational identification that was missing heretofore. Prior to 9/11, on the day of 9/11, the head of the President of the United States tasked the head of the Navy to look at what our vulnerabilities were to maritime terrorism. It came down the chain of command like a lightning bolt and landed on my desk at about 07:45 the next day, 9/12/2001. I've been working on that. But until 9/11, we had all of these assets out there that really weren't talking to each other. They had no common frame of reference. This was actually the report out that we did in responding back to the president. We said, these are all the systems you need to tie together. This brief was written actually in late 2001. It's been refined many times since then. This is actually the presentation of updated up to March of 2003. That's when we added these acoustic systems in it. It says April is when this was written. Maritime Domain Awareness Program Integration Office was created in April of 2003. This was to build, our task was to build the collaborative information environment in the maritime domain. We've been working on it ever since. People still today trying to build this. I was the science advisor of Maritime Domain Awareness basically from 2001 until 2003. The job wasn't created until 2003, but I'd been doing that job for 2001. We looked at every platform from satellites to undersea vehicles, every sensor, processing system, fusion system, analysis system, display, decision aid, and dissemination system, communication systems. By mid-2005, as I mentioned earlier, commercial space was obviously a core capability. If we didn't have that, we were never going to have safety at sea. This brief is a report of that research, which started, as I say, on the day after 9/11, still on goes today. Every sensor. Global maritime awareness is what I call it. It's basically the combination of maritime domain awareness and maritime situation awareness, which most people think the same, but aren't. They were created for two different jobs. I know because I was there at the time. Global maritime awareness, what exactly is it? It's maritime domain awareness. All is probably the easiest. By all, I mean everybody on Earth. Why GMA? Why do you need it? What's the importance of GMA, global maritime awareness? I'll explain it. Maritime security is essential to a nation's well-being. Maritime security is actually directly proportional to its maritime situation awareness. Thus, MSA equals MSA, maritime security, maritime situation awareness equals maritime security. This is true all over the world. We all need it. So therefore, if we have global maritime awareness, we will actually have a more secure world globally. Advances in numbers of unclassified systems, and there are coming. There's amazing numbers. When I first started talking about what they were happening, we were talking maybe 1,000 or so. We're up to something like 12,000 unclassified Earth observation capabilities, 12,000 new commercial satellites in space. About 3,000 of them are going to have Earth observation capabilities. The rest of them are either going to be the research satellites or communication satellites, one of another. And also, we all know, and it's in the news every day, that there's been an amazing explosion in the IT world, in the data processing systems. You marry the IT world with the space systems world, and you can build a global maritime system today. Excellent. Therefore, it would significantly improve life on Earth. This is the message we've been trying to get across literally since 2006. In 2010, and this is what we're going to need to do this. It'll be able to allow us to counter smuggling, drugs, people, arms, counterband, and counter piracy. It'll also directly assist our maritime safety, environmental protection, resource protection. It'll also assist in disaster mitigation, and it absolutely helps in disaster recovery. It would be feasible, we believe, and we've studied this significantly many times, many places now in the last 15 years, at one center could allow for the global coordination and collaboration of all space assets in the maritime that are useful for maritime situation awareness. In 2010, actually about 5 months after President Obama came in to be our president back in 2009, he had a meeting there in the White House of all of his secretaries, Commerce, State, Transportation, and said, we need to use space as a way to help enhance life on Earth. And I became part of that team because I'd been writing about it. And in fact, they took the preamble to one of my papers and used it as the start of the tasking that they sent to all the secretaries of Defense, Homeland Security, Transportation, et cetera. And so they invited me to be part of it. And we wrote this. This is what it says to do. This has never been enacted in the United States, even though it was implementation task number 1 of our 2010 space policy. I spent 9 months campaigning and arguing to get it to be part of the 16 implementation tasks that were part of our national space policy. And then a mid-grade bureaucrat in the Secretary of the Navy's office decided that this was a threat to the Navy and refused to go forward with it. You don't think that was frustrating? You don't know what the word frustrating means. It's never been done. It still needs to be done. It is, back then it was a pipe dream. We were talking, the systems were coming. We knew they were coming. They're here today and they're only going to get better. That's what most of the rest of my brief, and why it takes another hour to give it, is I give a description of all 7 of the different types of satellites you would use to build this system. Global AIS data. This is 1 day's worth of tracking from the Orbcomm system. There are 3 systems out there, Orbcomm, Spire, and Exact Earth. You add those 3 together and you are looking at less than a minute lateness of every AIS transmission in the world. You also have imaging systems that are now coming into play, especially the synthetic aperture radars. You can operate rain or shine, clouds, night, all the time. And we're talking about having 50 of those up within the next couple of years. We're also going to have something like 30 satellites that will be reading the ships of radars, and at least 2 of those systems. There are 4 companies building them now. 2 of them can actually fingerprint the radar to tell you what specific ship that is on. And there are over 1 million ships that we will be tracking, but with the data systems that are there today, the cyber world, the machine learning, the big data systems that are being brought into use of this is very feasible. Terrestrial AIS also provides real-time coverage in many locations. This is just the Orbcomm system, has 19 satellites plus 16 ground stations. Spire has over 100 satellites in there with 32 ground stations. Orbcomm was the people that built my first satellite, and I'm very beholden to do that. But there's also another 58 satellites on Exact Earth. All of these are in orbits that bring them over the Earth's surface many times a day. Space systems, people say, oh, they cost too much. No, they don't. They actually make your terrestrial system dramatically more effective. They make your ships and planes, instead of going out and boring holes in the ocean, they go to look at something specific that has been told them. Why are we getting an image of a ship out there and we're not seeing any AIS? It should be. Now, is it in distress, or is it somebody that's trying to smuggle something? We generally now know enough about the histories of ships we've been tracking using AIS. We now have over 1 million ships in our database. It tells you decision makers where to pinpoint your search. It's been a huge saving on wear and tear on your terrestrial systems, on your ships, on your crews, on your planes. They now go out in directed search rather than just bore holes in the sky. It is a dramatic increase in terrestrial system. This is what it's going to look like in the immediate future. These are the 6 of the 7 satellites out there. Satellite AIS, we've just been talking about. We're going to have comment systems here pretty quickly. Any day now, actually. It's the first comment satellite, communications intelligence satellite, is on the pad today. Synthetic aperture radar satellites. 175 satellite AIS systems on orbit today. We're probably going to top out somewhere around 250. SARS, about 20 today, probably going to have 150 in the next 2 years. Optical, we have at least 82. That's probably low now. It's probably more like over 100. Who knows where the number is? Everybody continues to put up optical systems all the time. Video, we have 4 video cameras in space. Bill Gates was going to put 300 up. He's backed away from that plan. Who knows? But somebody's going to start putting up lots of video. Video is a really interesting system. It has come a long way in the last 5 years. Video in space. SIGINT systems, I believe we have 8. We're soon to have over 12, probably as many as 15 by the end of 2021. M2M and IoT, that's a machine to machine. We have 52 of those satellites today. There are about 10 different companies that tell us they're going to be putting up IoT systems. There's a big Australian effort underway to put up over 100 IoT, Internet of Things satellites. Huge number of those going up. Why those are important is ships often use them. We call them SMS, short message systems. It's also called the texting system. That probably is what most people know. But M2M has been around for 30 years. Most people didn't know it, machine to machine. Never even heard of it, but it's a very big thing, and it will give us lots of, and a lot of ships have it. It will give us lots of insights. That's how they report. You may remember the Malaysian aircraft that disappeared 5 or 6 years ago. Well, the reason we finally figured out where it probably had gone was we tracked the Doppler shift to the off of its M2M reporting. It had a sensor on its engines telling us when they were running and at what speed they were running. And that gave us a lot of information, and we were able to direction find off that information. They were talking to a satellite, and we could see the Doppler shift on the satellite. Doppler shift is when you go from a positive speed across the sound of the side of the line of sight. And if it's going up, it means you're coming toward them. If it's going away, it means you're going away from them. And you can track that by the variations of what that is. The closer, the more direct it is, the faster it goes up, and you know what speed the aircraft is tracking in. So that's a constant. And if it's going down at a constant speed, that means you're going directly away from it. But if it's a variable speed, it means you're traveling diagonal to the satellite. I've attended many, many meetings that have said this. Basically, we need to establish a global maritime domain awareness. We need to coordinate synchronization. We need to develop common command procedures and coordination. We need to develop linkage between all the different maritime domain organizations of the world. Well, guess what? Satellites, if you were building that satellite system, the global maritime awareness system I'm talking about, you'd have to do all that. I believe that if we develop this system, much like it took over 40 years to build the air traffic control system for commercial airlines, we need to do the same thing in space for ships. And space systems give us that technological capability today. As I've said before we didn't have a location identification tool. Satellite AIS gives that to us. It is what provides the maritime global frame of reference. It makes it feasible. Without it, you couldn't. It is now paired with the radar systems that I mentioned before, day and night. Optical systems are very important, but they only operate during day when it's cloudy, when it's not cloudy, I'm sorry. We also need to build a dynamic data fusion system. I actually drew this chart in late 2001. I've used it many times. The reason I even thought in these terms is these 4 boxes that just flew in from the side here were systems that I had all worked on, and they were ways to defeat that cycle down there: sense, process, fuse, analyze, decide, act, of the Soviet air defense systems. And these were all different ways we were going to counter it, going to exploit it and counter it. We'd spent back literally almost 20 years ago now, we spent over $105 million building these 4 boxes right here. These boxes today give us the technology to build this common distributed virtual database and information extraction tool. What these white boxes that I've just popped up here in the gray and black this is the databases that we need. This is the underpinning. And some of them are in fact classified, highly classified. That's the black ones. Some of them are sort of classified over here. That's the gray ones. And a little more classified are the ones in dark gray. The names up here are all databases that are in existence today. I defined this. This is now called the cloud. This was just before the cloud came into being. But the way ahead is to figure out a way to use smart agents, which is a tool within artificial intelligence and machine learning, to do the control process, to do the automatic detection process, and to do the data mining process. Then once your sensor picks up something, it sends it up and it operates on that. And then you process that information to give you more knowledge. And you fuse it, you analyze it to give yourself understanding. You make your decision of what you're going to do. And hopefully the decision maker in this box right here gives you a smart order. He employs wisdom. So you go from phenomenology to data, to information, to knowledge, to understanding, to wisdom. That's what this tells you right here. And there's systems that build that right today. This was, as we looked at more and more systems, we all remember Karl Marx in 1848, who said, "From each according to their ability, to each according to their needs." Well, I have applied that to maritime domain awareness. We people in the free nations of goodwill need to do the same thing. We all need to work together, from each according to their capabilities, to each according to their needs. The folks in the South Oceans, especially Africa, South America, New Zealand, Australia, have a huge exploitation of their natural resources. We need to all work together to help that. This is nowhere more true than space-based MSA. We all need to work together to do that. We would make for a better, safer world. And that's it, my friends. I look forward to your questions. As I say, I've been studying this for a number of years now, and I'm ready, willing, and able to help.
Weather has a way of complicating not only the way we navigate our oceans, but also how we understand activity on our oceans from space. Mr. Ray Gofer, co-founder of Tomorrowio, will join us today to help us understand how remote sensing of meteorological and oceanic data, or METOC data, contributes to our ocean's situational awareness.
So hello, everybody, and welcome to Tomorrowio, the only weather intelligence platform for a changing climate. Our mission is to help countries, businesses, and individuals better manage their ever-growing environmental-related challenges, and we're extremely passionate about our mission. Just briefly on myself, so I'm Ray Gofer. I'm one of the co-founders and chief strategy officer of the company. My background is I'm from Israel. I spent about a decade in the Israeli Air Force as a pilot, and then I moved to Boston and went to grad school here. And I lead our space team and government relations as well. So the context is obviously about climate. Climate is the biggest challenge we're facing in this century. It's the next economic frontier. And climate eventually translates to weather, right? Climate is kind of the long-term average. Weather is what happens today, next week. And if you're looking at this chart here, you're seeing the massive increase in extreme weather events over the last few decades. And unfortunately, that increase is not expected to stop, at least for the next few decades. And that is if we are doing a great job in stopping, carbon emissions. And so the cost here is really in the trillions for everybody from countries, businesses, and individuals. Numbers are really astounding, both for the entire global economy as well as for specific companies and government agencies. And really the way we think about it is that in this new world, weather intelligence essentially becomes a necessity, very much like cybersecurity is for any company today, any organization. This is, of course, a very vivid example of what happens when you are not really acting according to what the weather will do, and you can cause damages in the billions and billions of dollars, right? And so our goal is to help every organization in the world be able to not just know what the weather will be, but exactly know what they should do about it. I'll give one example before I talk about our technology and how we do that. I just want to maybe give some color about exactly how we do it. This is a company we work with in India, IndiGrid. It's one of the largest power utilities in India. And our platform actually enabled IndiGrid really a couple of days after they onboarded to start using it, came this massive tropical cyclone Amphan. And usually when such storms reach India, which happens a few times every year, it's really hard to say what exactly is going to happen in a local level and then what do we need to do about it. It's kind of this massive storm that hits the subcontinent and just hope for it to go. But in our case, we were able to help IndiGrid really identify the very specific locations on their grid where the storm, specifically strong winds and precipitation, were about to hit, and notify them with not just like, here's the storm, but here's what you need to do. You need to pre-position crews in these locations, in those times, and that enabled them to prevent massive power shutdowns for huge portions of the country, really using our software. So the impact was massive, and that's just one of many examples of how weather intelligence can help businesses, organizations, governments to really cope with the damages that Mother Earth brings to us. So when we were zooming out and we think about the weather ecosystem today, the vast majority of the technology is led and provided by governmental agencies. So NOAA, for example, in the US, the European Union, et cetera, which really has two issues. One is that most countries are still blind to weather data because they don't have the same budgets that, say, the US has to spend on weather infrastructure. And then the other piece of it is that businesses are still reactive to weather events because the weather agencies, the national weather services, provide us the forecast, but they don't really tell us on a very specific level to each individual, each organization, what they have to do about it. On the other side, the private weather players really just repackage this governmental data. They lack accuracy, of course, resolution and coverage because of what I just explained, but also because of the very kind of multidimensionality of weather, it impacts so many different industries. Nobody was able to build a software tool that addresses all these different types of problems. And so what ends up being is people just provide services like a weatherman on the phone, but that really doesn't scale well, and you can't reach to, for example, the captain of this ship that hit the wall of the Suez Canal. And the weather data they provide is really just raw, and it's not actionable for businesses. And so that's the current situation. Now, zooming out even more, when we look about at the entire globe, we see that weather data is still very unequal. So there are countries where you have relatively decent coverage, say radars in this case, but these are very few countries and very small portion of the entire globe. The vast majority of the world, over 5 billion people, and of course, all of the oceans, do not have radar coverage. Radars are the most critical sensor we have for sensing the atmosphere and sensing, for example, waves, etc. That we still do not have. And the reason is we're trying to do it in the old way, which is deploying it on the ground. That is very expensive, and it just doesn't scale well, and it costs so many different operational complexities. what we have from space today does not provide the same kind of data, the same instruments that radars are. We have passive sensors that are very, very limited in what they can tell us about the atmosphere and the oceans. So the only way to solve this problem is really reinventing radars from space and deploying them in a constellation. And this is what Tomorrow is doing. So our approach is very unique, and we have spent over 2 years in designing a new type of weather radar that can fit on a very small satellite, about the size of a mini fridge. And with that, basically, because it is about 50 times smaller than what's currently flying in space, we can deploy many of those. And once you have many of these, you can actually hit very high revisit rates, meaning you can see every point on the ground very frequently, and really radically changing weather forecasting and climate science all around the globe. This is actually a quote from NASA talking about this problem. So our technology essentially combines a set of unique observations, public data, of course, another technology we invented early on, which is called Weather of Things, essentially using all sorts of instruments like sensors on ships, etc., vessels, and of course our space constellation, together with proprietary and global forecasting models, all feeding a machine learning engine that spits out very accurate weather data forecast in real time for everywhere in the globe, which we then provide via a suite of software tools that are useful for operators, developers, consumers, and others. We have a very strong R&D team with many unique capabilities and about 65 people working on this technology. We're really bringing a revolution with this technology. So once we're done deploying our satellites, which is about 3 years from now, we will be able to track every single storm in the globe from Genesis all the way until it hits our coast, or if we're talking about maritime activity and route monitoring in very high granularity, and really enable us to have kind of the situational awareness and forecasting capabilities that were imagined. Basically, people thought it was not possible, but we're going to do it. And all of this is then feeding our multi-vertical platforms. So our SaaS solutions, essentially, I'll show a screenshot, offer capabilities for any type of user, any type of industry, maritime, military, aviation, and whatnot, with global coverage. The value we provide really is unique in 3 different levels. It starts with proprietary technology, which I just explained, the satellites, our models, our sensing technologies, and then the solution that are very robust and configurable software as a service versus people on the phone trying to answer your questions. And eventually, the most important thing is that we're focusing on basically the impact. We're predicting the impact that weather and the environment will have on your operations and telling you what you should do about it. So in the example of maritime activity, this is looking at cargo operation in a port. And basically, instead of looking at just a map of the weather, what you will see here is things like suspend cranes, lightning and thunder are coming between 12 p.m. and 4 p.m., protect the equipment because of hail risk between, etc. So that is really a radical change from somebody looking at a map and trying to understand what they should do to basically just being notified by this dashboard about the exact actions you need to take in your specific location for your specific type of operation. In this context, again, port operations and cargo. Our strategy is basically a vertically integrated company looking at the SaaS platform as our main offering and the way people basically solve problems. We feed it with our space constellation and our weather models, which essentially feed each other and help our platform become better than anything else that could work with just government data and regular type of models. Don't take it from me, take it from many of our customers. We serve a huge host of customers in many different industries, all the way from aviation, transportation, mobility, energy, sports, military, maritime activities, and many others. But this really is becoming the standard for climate resiliency and weather operations in every type of enterprise business. So with that, I want to thank you for listening, and I'll be happy to take questions. Thank you very much.
When weather strikes, many forms of satellite remote sensing do not work. Radar, however, offers an all-weather view of our planet, seeing through the worst of storms. Mr. Tom Ager, president of Tom Ager LLC, will walk us through the intricacies of synthetic aperture radar.
Okay, hi, my name is Tom Ager. I'm going to present an overview of maritime applications of SAR. And I wanted to say first, I used to manage the SAR program at NGA. However, I am not a legitimate electrical engineer. I'm trained in photogrammetry in graduate school. And I'm happy to say for this group, I have a second graduate degree in geography from the University of Hawaii. Very long ago. I just checked, that was 39 years ago. All right, so we'll begin this by pointing out first that we live on planet Ocean. We may call this place Earth, but 70% of the surface area of this planet is water, and we have massive cloud cover. We hear all the time about the cloud belt around the equator, but take a look at the Southern Ocean and the far northern seas. Also, this planet is dark half the time. So we need long wavelengths. Optical sensors are wonderful. Our brains are tuned to them. But for guaranteed imaging on this planet, we also need active sensors that use long electromagnetic waves to see through clouds and darkness. We need microwaves because once you get to around 1 centimeter in wavelength, there's an atmospheric window that opens up and microwaves penetrate our atmosphere. SAR uses a radar form of microwaves, and it can create images and many other products. Our first image then is an MSI image over Lake Maracaibo, and you can see all of these oil derricks in that lake. Let's see what a SAR image looks like over the same area. And they light up like beacons in the night. So rather than running through for you different use cases of SAR, I'd rather teach you a little bit about SAR characteristics that impact the maritime environment so you can imagine for yourself how it might be used. First thing that matters is direction of illumination. So consider here we're imaging the ground and the energy's heading down to this specular reflector, calm water surface. And it's getting reflected away from the antenna, so you're going to have a dark pixel. In these areas here where there are some features, some structure, you're going to have diffuse return and gray pixels. In this region, the energy is hitting the ground, bouncing off the side of the Lincoln Memorial, and you're going to have a very bright pixel. Trihedrals are corner reflectors. Whoops, excuse me. They're cubic structures that reflect energy exactly back to the direction they came in from. So if they come in this direction, it's going to go right back to the sensor. If it came in from this direction, right back to the sensor. So trihedrals give very bright, glinting reflections. Nature doesn't tend to work with cubic things. So cubic reflections tend to be human-made objects, and they're very common on ships. Reaction to an electric field. The dielectric constant is a measure of how well electric field passes through a material. A high value means strong reflectance, and take a look at water and metal. Very high reflectance of microwaves. So those oil rigs in Lake Maracaibo, tall metal things with many crisscrossing trihedral reflectors, bright. Here's a ship. Energy's coming down in this direction. I'm getting a dihedral reflection from this side, very bright pixels. The ship is metal. So all of these structures here over the cargo bays are showing up. The water in this case is calm. It's a specular reflection, giving me a very strong reflection, but away from the antenna, dark. And I can see these ships beautifully. The Straits of Singapore is one of the most active ship transit areas in the world. About 2,000 ships a day pass through these waters. You can see them all here, and you can see some of their wakes as they pass by Singapore. SAR is so good at ship detection that it's often combined with AIS data to look for dark vessels that are not emitting. In this case, this one's not emitting AIS. We found it. We know where it is, the time, and what kind of ship it is. Wind. Wind disturbs the water surface and shows up. Even small ripples can be very obvious. Here's a RadarSat-2 image of the Strait of Gibraltar, and we can see so much water texture. SAR has been used to measure wave structures, ocean currents, wind direction, and speed. Polarization of our pulses. SAR is an active system, so we generate the pulses ourselves, and we can determine what structure of the pulse we want to use. If the electric field is vertical, as in this case, that's called vertical polarization. If it's horizontal, that's called horizontal polarization. And we can choose to send out a vertical pulse or a horizontal pulse. Usually, we send out a vertical pulse and record the vertical reflection, or a horizontal pulse and record the horizontal reflection. But polarization is sometimes twisted on reflection. The portion that is flipped 90 degrees can be recorded. So it's possible to do a cross-pole image, send out a vertical pulse, record the horizontal reflection, or send out a horizontal pulse and record the vertical reflection. In this case, RadarSat's doing both. It sent out, it created a VV image over here, that's the one we saw earlier, and at the same time, created a VH image, and look how different the reflection pattern is. Flat surfaces do not tend to flip the polarization. So therefore, the H return here is weak, and we can see all the ships in this area. Together, these things give us a lot of information about what's happening. This is called dual pole imaging. Surface texture. SAR is really sensitive to surface texture changes, even at the level of a single wavelength. So here we have the deep water horizon oil spill, and look, oil and water don't mix. Oil smooths out the water surface. It's acting like a specular reflector, and I can see it so clearly. Whereas the waves in the water are showing up, the ships are showing up, their wakes are showing up. Beautiful image. In fact, RadarSat-2, Cosmos, SkyMed, and TerraSAR-X were the main sensors used to track that oil spill. Not only can you see the oil, they're also capable of very wide swath collections. Ice. Radar is really good for ice detection. HH is a good choice because it suppresses ocean clutter. Dual pole, of course, is better. It's going to give you both kinds of reflections. Really bad weather. Radar is called all weather. It's not. Here, massive thunder clouds are showing up in the radar images. This is the south coast of Louisiana. Time. Radar is not going to let you down when you need an image. And it can repeat the same collection over time with exactly the same geometry. So here we are in the English Channel. Collection over many weeks or even maybe a few months, and we see thousands of ships and their patterns so clearly. These features here are wind turbines, tall metal things out in the ocean that we can see so clearly. Motion. Objects that are in motion are often displaced from their actual location. This is TerraSAR-X image. In this case, the satellite was moving down this way. That's called the azimuth direction. It was sending its energy out this way. That is called the range direction. An object moving in the range direction is displaced because of the Doppler shift from its actual location. We can see the ship here. Here's its wake that it's displaced. All of these ships moving in the range direction are displaced from their actual locations. This guy is moving in azimuth. He's not displaced. Let's take a closer look at this. Here's his ship displaced. If you measured this distance, you'd know how fast that ship is moving. This guy moving in azimuth, he's not displaced, but his signature, because he moves in azimuth, is defocused. focusing a ship. Remember, radar is a coherent system. That is, we control the pulses. We control the structure of the pulses. The pulses are consistent, pulse to pulse, image to image. We can measure, therefore, the phase of the return. That is, when the wave hits the antenna, is it at its peak, trough, or someplace in between? That's called the phase. A complex image has both amplitude and phase measurements for each pixel. And that allows you to process the image in ways you cannot with only amplitude data. So suppose in this case here, we have a complex image in the background. And we have some code running on an inexpensive gaming machine GPU. What we're going to do is move these slide bars. This slide bar is going to model the motion of the ship, the roll of the ship in this direction. This one's going to model the pitch of the ship. And as we move these slide bars, we're going to reform the image using the complex data and our gaming machine GPU in real time. We're going to keep moving those slide bars around until we see this. That's what you can do with complex data and cheap commodity hardware. Watch out for the small SARs. Several small SARs have already launched some satellites. Capella in the United States, ISI in Finland, and now the United States already has several very small SARs in orbit. Synspective is a Japanese company that's already launched one. And in the United States, we have some other companies, Orbital FX, Predasar, and Umbra. All of these companies intend on launching large constellations of small radar satellites. Here's an image from one of the little ISAR satellites of the Gulf of Suez. This image was taken right after the Ever Given was released, and ship traffic is now moving through the canal. You can see them here, lit up, moving through here. And we can see all these ships backed up, waiting to go through. Notice, too, how nicely SAR shows topography. It shows up very, very nicely. So this image from this little SAR would be really impressive if that were the image, but it's not. Let's keep moving to the left with the same image. We're moving to the left, which is north. And there's the town of Suez. All the ships lit up, moving through the canal. We see them easily. This is interesting. So let's keep moving. And we go to the left, and we see Great Bitter Lake and all the ships moored in there. And we see some agricultural fields. And on this same image, we'll keep moving north, and we see Port Said. And here we see the ships waiting to go south. We know they're heading south. This guy, we see the ship, we see its wake. These guys are heading into the canal, heading south. This is interesting, this aggregation of ships. So let's keep moving out into the Mediterranean and look at the rest of them, all on a single small SAR image. This mode is called scan mode. For ISI, it's a new mode, it's experimental, but you can be sure it's going to be operational really soon. So SAR is really good for maritime applications. Why? Because you get guaranteed access, because it's capable of wide swaths, because there is a revolution in ship detection and tracking underway using SAR, AIS, and passive radio frequency systems like Hawkeye 360 that can detect maritime radio transmissions, because you get strong signatures for oil spills, ice, glaciers. Scientists are studying waves, winds, and currents. Many small SARs are being launched, and ease of access and speed of delivery will improve. If you'd like more information, there is an issue of Oceanography magazine entirely devoted to ocean remote sensing with synthetic aperture radar. And there's a book about to be published. I know about it because I spent the last 4 years writing it. And I'm not mentioning it here to promote myself. I'm mentioning it because we need a comprehensive review of SAR for remote sensing professionals and students who are not electrical engineers. They need something they can read. We need it because SAR is a beautiful and enigmatic sensor, well suited to imaging on an ocean planet. Thank you.
While AIS collects location data intentionally sent by AIS beacons, it is possible to track all sorts of ocean activity where the mariners are less compliant through their radio frequency emanations, or RF emanations. The Honorable Carrie Bingen, former Principal Deputy Undersecretary of Intelligence and current Chief Strategy Officer at Hawkeye 360, will help us better understand how such RF data can be observed from space and the advantages it offers national security decision makers.
Thanks, Dr. Tucker. It's great to virtually see you again. And thank you to the American Geographical Society. I appreciate the opportunity to be with you today and to discuss how we can improve our situational awareness of the oceans for national security missions. And I commend you all on your work in promoting the responsible stewardship of the vast natural resource that is our oceans. Next slide. I'd like to start on a personal note and share a fairly crude picture from my iPhone, but a picture of an antique map that hangs prominently in my living room. This is North America, published in 1814 for John Thomson's New General Atlas. Thomson was one of the leading British cartographers in the early 19th century. The level of detail in his map was considered a breakthrough in British cartography at the time. He earned a great deal of attention, and his work was copied for a number of years. Thomson's mapping of the lakes and rivers to the west of the Great Lakes and Hudson's Bay is quite detailed and provides good information, drawn heavily from British and French explorers. But his rendering of the American West out to the Pacific Ocean is still lacking, with only limited information from Lewis and Clark, whose expedition journals had just been published. But what I find intriguing is that it's mapping something new, with new sources of information and making that information more accessible to a broader population. And it's that same intrigue that drew me to Hawkeye 360. Next slide. Hawkeye 360 is a trailblazer and innovator in commercial radio frequency RF remote sensing. Increasingly, the lifeblood of our modern digital world is carried by the RF spectrum. We operate clusters of formation flying satellites at low Earth orbit that can detect and geolocate a broad range of signals across the RF spectrum, across the globe, from beacons on ships to navigational radars to push-to-talk radios and mobile satellite devices. Combining this RF signal information with other data sources and advanced analytics is enabling us to create a new RF geospatial data layer for the planet and is revealing deeper insights on patterns of activity and behavior at sea or on land, the impacts of changes in the environment, and providing indications and warning of anomalous or suspicious activity. Next slide. So what does an RF geospatial data layer for the planet look like? This is 2 years worth of geolocated global maritime signals, over 24 million signals collected that form the basis of our insights, situational awareness, trends, pattern of life mapping, and behavioral analysis across the vast maritime domain. Next slide. So the commercial space landscape has changed dramatically in the last 20 years, spurred by advances in technology and unprecedented private sector investment. Hawkeye is at the leading edge of this, advancing US technological innovation in commercial space and disrupting a space technology area that until recently was solely within the domain of governments. I'd like to emphasize that we are a small, agile commercial company leveraging private sector investment to provide RF capabilities to national security, foreign partner, and commercial users. Earlier this year, we launched our second cluster of satellites and released the first commercial RF analysis platform for maritime domain awareness, Mission Space, which was purpose-built to bridge the interpretation gap between the collection and analysis of RF data. The RF data we collect is unclassified and shareable. With allies and partners, academia, and the public, it is a new geospatial data layer for many of our allies and partners whose maritime security challenges are immense. We are increasing the diversity and resiliency of overhead architectures in an affordable manner and enabling users to experiment with new operating concepts, distribution pathways, and acquisition models. With our satellites on near quarterly launch centers, we are leveraging faster development and fielding cycles, greater technology refresh rates, and broadening the bench of American STEM talent working to advance US space leadership. Next slide. So I'd like to take the opportunity to share some of the insights we're developing through the application of this new commercial RF geospatial data layer to improve our situational awareness across the oceans. Next slide. The Arctic. As the ice caps melt each summer in the Arctic, Hawkeye is able to detect and map increased maritime activity, particularly during August and September. We see vessel routes not visible in AIS and movement across the sea ice. We're able to map traffic patterns and concentration of vessels. We've observed a heavy dominance of Russian vessel activity when compared to other nations. And through the tipping and queuing of other sensors, we can capture images where we identify a concentration of RF. In one example, we documented a Russian outpost on an Arctic island. So through greater situational awareness, we're enhancing our understanding of the security implications of climate change in the Arctic. Next slide. Exclusive economic zones, or EEZs. Monitoring is essential for a country to properly police its exclusive economic zones and prevent encroachment by foreign entities. But the vast ocean expanses make it incredibly difficult to find vessels that may be participating in illegal fishing, especially when they turn off their automatic identification system, AIS, as has been reported about the Chinese fishing fleet. In the summer of 2020, Hawkeye monitored the Galapagos Islands to improve situational awareness of the Chinese fishing fleet behavior near Ecuador's EEZ surrounding the islands. Our analysis revealed Chinese vessels attempting to hide by deactivating AIS tracking. And we discovered evidence of illegal fishing in combination with imagery sources we queued with multiple instances of dark vessels operating within the Galapagos EEZ. We're building a more complete picture of maritime activity to safeguard natural resources and to provide indications and warnings of incursions into protected zones. Bringing these previously hidden activities to light enables authorities to act quickly and confidently and provides a powerful deterrence to further illegal behaviors. Next slide. Searching for an elusive tanker. Sanctioned countries, such as Iran, regularly seek to evade US sanctions, relying heavily on oil for funding. To investigate these activities, we examined how Iran might be using its tanker fleet to smuggle large amounts of crude oil through the Mediterranean into Syria for sale. In one instance, with Hawkeye's RF geolocation capability, we traced the path of a suspected tanker through the Gulf of Suez, despite going dark and turning off its AIS, into the Mediterranean where it went dark again. In concert with collected imagery, we identified the vessel in port in Iran and then later at a refinery in Syria. So when AIS is not able to supply enough knowledge, other data sources are critical for developing comprehensive maritime awareness that support assessments of suspicious vessel activity, can monitor vessel rendezvous, and enable sanctions enforcement and counter-smuggling operations. Next slide. So economic. Hawkeye's data can also serve as an unbiased barometer of economic activity, particularly in the maritime domain, by providing insights into vessel activity in regions around the world. For example, last March, when Italy entered countrywide lockdowns due to COVID-19, Hawkeye saw an immediate drop in maritime activity through the monitoring of marine radars. Shipping and tourism in Italy were heavily impacted. Hawkeye's RF data also provided a transparent, independent alternative by which to gauge Chinese claims of economic recovery in Wuhan and other Chinese cities by measuring changes in patterns of vessel behavior and analyzing vessel movements in port. Monitoring maritime traffic can be a potential indicator for gauging economic activity. Next slide. So in conclusion, these are just a select subset of the national and international security applications that this new RF geospatial data layer is contributing to. Like Thomson's 1914 map, a breakthrough in cartography with new sources of information, Hawkeye is today's new source of information, leading to deeper insights and understanding about global activity across our vast oceans, and their implications for our national security. Thank you.
This collection of experts has educated all of us on how different space-based remote sensing platforms help us understand and secure our oceans. Different phenomenologies, along with different levels of persistence and revisit rates, offer us so many different possibilities. But it's how we use them together that really matters when we address our priority maritime national security questions from space. We are fortunate to have AGS counselor Keith Masbach, an expert in his own right, to lead a panel discussion amongst these experts to tease out the larger issues that we must together consider. Before Keith became a strategic advisor to the commercial remote sensing industry, he was actually the national security leader in charge of tasking America's constellation of spy satellites to address just such questions. Keith has served as the chairman of the National Geospatial Advisory Committee, the CEO of the United States Geospatial Intelligence Foundation, a member of the intelligence community's senior executive service, and an intelligence officer in the U.S. Army. We could not be in better hands for this discussion. I'm excited to learn how our experts see these different kinds of satellites working together to help the U.S. national security community and our global community secure our oceans into the future.
Thanks so much, Chris. We appreciate the opportunity to get together today to talk about this critically important topic. Welcoming back the folks who we've had a chance to hear from already. Just to review, we've got Tom Ager, Carrie Bingen, Ray Gofer, Jen Marcus, Brian Smith, and Guy Thomas. And welcome to all of you. I appreciate you taking the time to talk about this today. And I think it'll be an interesting discussion given the variety of backgrounds and expertise represented on the panel. So with that, I'd like to just jump in and get to the first question to start the discussion. As we think about at the macro level about remote sensing and evolving remote sensing capabilities, how do you see the future unfolding as it relates to our oceans? Ray, do you have some thoughts on that to get started?
Happy to start. Great being here. So I think the maybe three key themes, and I think it's, by the way, true for any domain of remote sensing, not just the oceans, but definitely for the oceans. I think one, and that's kind of me saying it from a commercial company, but it's commercial, right? So we'll see more and more commercial entities taking the lead and bringing new innovation, new systems faster, cheaper, and that's one. The second one will be distributed. So we'll see more systems that are composed of many more nodes that are smaller and probably as capable, but are far cheaper and therefore are more robust. And we have just better sensing, again, both remote and in situ. And then I think the last one is really kind of agile, right? Agility. So we will have systems that take far less time to develop and deploy, and basically will get kind of much newer technology being implemented at all times.
So Ray, thank you. I think you've given a good construct for all of us to think about this. Does anybody else have some thoughts on that first question?
Yeah, it's Tom Ager. Just to say that in the case of SAR, there's going to be an exponential growth in capacity and coverage. Capacity is going up not a little bit, exponentially, and costs will drop. That's it.
And I'll just jump in and echo the comments around the proliferation of sensors. And I think with that, what you're going to find is that detection is going to become much more of a commodity. Today, a lot of the goal is to detect dark vessels. And I think where you're going to see the industry head is, as opposed to trying to just know where everything is, they're going to be inundated with data, trying to find that needle in a haystack of the vessels that matter. And I think being able to identify vessels is going to be a critical component to allow for successful interdiction, and where the industry and commercial entities need to drive.
I'd like to add on to that, one that hasn't been mentioned. I second Tom's remark right there, and Brian's too, and Ray's as well. But nobody's mentioned the RF geolocation systems, which I call SIGINT-SATs or SIG-SATs to make it really easy. Paired with satellite AIS and the SARs, the oceans are going to become one heck of a lot more transparent, especially as there's already about 6 or 7 of those RF geolocation systems up. Some of the people are not talking about their ability to fingerprint, but we're going to be able to fingerprint a lot of these radars out there. Not all of them, but a lot of them. And we're going to you tie that into the radar to AIS. If you catch them as they leave port, we're going to know who a lot of the ships are out there. That's going to be a game changer.
So, Carrie, I'm thinking you might have something to say on this.
No, that's a great segue, and I promise I did not pay him. And Carrie Bingen representing Hawkeye 360, but I absolutely agree. And 3 aspects that I'd hit on that a couple have as well is the technology. We're seeing a proliferation of space technology, more sensors, more phenomenologies. Second, explosion of commercial, I shouldn't say explosion in space, but expansion of commercial in areas that were formerly reserved for nation states, which is pretty phenomenal. So SAR, hyperspectral, RF, that was just mentioned. And the other interesting thing here is investment. We're seeing record private investment in startup space ventures and space companies overall. And that is cost avoidance and risk avoidance to the government, because taxpayer dollars are not being spent on that R&D, but then they're getting the benefit of leveraging that data and product.
So, Jen, I'm wondering if you might talk to us a little bit about the value of cadence in all this, right? And the idea of spatial resolution versus temporal resolution versus spectral.
Sure. And thanks for moderating here, Keith. And it's such a pleasure for me to be on the panel with all of you. What we say at Planet is you can't manage what you can't measure. And so what I agree wholeheartly with what everybody said about the proliferation of more technology and sensors in space and the investments. And what we have at Planet is the ability to take an image everywhere, every day, including over the oceans. And so having all of these additional sensors that you can fuse with EO over the open oceans, we're going to be able to manage and monitor oceans like never before. And I think of it in kind of in parallel to what we're doing for forestry on land. The Dove satellites were designed specifically to be able to see trees and to be able to count them and measure the impact of climate change. And we can start to do those same things both for what's going on in our oceans and also maritime protected areas, our coral reefs and things like that. So we'll be able to do a lot more proactive management of those types of things.
So we started off sort of thinking in the positive. What are the things that we're going to be able to do? What are the capabilities that are beginning to come together? The idea of taking multiple types of phenomenologies and bringing them together to give us a much more fulsome picture. Let me ask you to start off perhaps on this next one, Guy. We started with the optimistic. What would you characterize as sort of a vexing problem or two? What's something that worries you, even as all this new capability comes on, based on your experience? I'd like Guy to start, and then certainly anybody else chime in. What are some of the things that you think will be particularly challenging going forward, even in an environment rich with data?
Environment's rich with the data. We're going to overload a lot of our analysts. We need to do dynamic data analysis of all of these systems to bring everything together. We also, and that my earlier question, we're not in this alone. It's a global problem, and the worlds are a global problem. We need to figure out how to do this. In fact, our first implementation task of our national space policy of 2010 was build a system that tied all this together. For some reason, that has never been implemented. And it's a little bit frustrating because I know the guy real well. So does my wife that wrote that and spent 9 months selling the idea. And the fact that we are not working on it all together is bizarre. And by all together, I mean every nation on Earth. There's good actors and bad actors. We all know that. But we all ought to work together. Making the oceans much more transparent is a good thing. So we need to work on it. But I don't see anybody nodding their heads doing that.
If I could speak it up here too, I completely agree that all of that data and all those phenomenologies and all those different sensors and massive amounts of data coming in every day, the difficulty is how much data that is and how to get it into the right systems with the other complementary data sets so that decisions can be made and information and intelligence can be shared. The other challenge I see is in how do we measure truth within that transparency? What this is a commoditized. I think somebody said earlier. The sensors and data sets are starting to become commoditized, which means it's not just governments that hold them anymore. It's not just the United States government that holds it anymore. So what do we put in place in our systems to provide some veracity behind data that's out there?
I'd like to add another aspect of this. What's an elusive challenge? What we've just heard obviously is crucial. But there's another one, which I think is actually modest, but if we did, it'd be a complete revolution. And that is easy ordering and fast delivery of spaceborne remote sensing data, especially for SAR. SAR can guarantee you an image, so it needs to be fast. And right now, when you want to order an image, what do? You can send an email, you can call somebody and talk things over. Imagine having a smart digital assistant on your phone that's going to let you order stuff. Just doing what we do every day when we order stuff on the internet. Do that with spaceborne assets so that you can get an image quickly, have it delivered into the cloud, and you look at it on the same phone or tablet that you ordered it with. And for SAR, with all of these sensors up there, you could actually get stuff measured in minutes. Imagine, you talk about national security and military commands, of course, would need this, but what about all the civil agencies? Erupting volcanoes, do you want to wait and be slow with that? Floods, earthquakes, hurricanes, oil spills, all this stuff requires speed. So we need easy and fast access. And I want to just editorialize a little bit. I'm not interested in hearing about modeling and simulation about future architectures when we can't right now get data to people who need it easy and fast. Do that. Also not interested in artificial intelligence, machine learning revolutions when we can't just do this. Order, quick, fast delivery. That's a revolution.
I want to jump in on that one, just echo some of Tom's comments and talk a little bit about what we're doing at Maxar Technologies to provide easy ordering in the optical space. So what we have currently is an automated tipping mechanism so that we can bring very high resolution optical imagery to bear in an automated fashion. And we're also creating an API so that it enables machine to machine interfacing. So think any sort of proprietary maritime domain awareness system that you can hook into it. You can send alerts. You can send an optical task with a theoretical minimum of 25 minutes from tip to collection, demonstrated minimum of 40 minutes from tip to collection. And then we're delivering output with vessel detections, AIS correlations today, and median timelines of 3 hours after collection, and driving that towards 1 hour. So we're incredibly focused on that same kind of talk track, Tom, that you laid out. And I think that's a real game changer because you need the information quickly, you need to be responsive. You also need to deliver in timelines of action so that it has the impact that it potentially can.
Carrie?
Sure. I want to pick up on Tom's point because I thought that was really interesting. We've talked a bit about what happens after the data is collected. There's processing analysis, but it's also that distribution piece. It's being timely and relevant and getting it to the users that need it. The other aspect of this, when we talk national security challenges, is that someone mentioned that needle in the haystack earlier. But these are called hard targets and national security challenges for a reason. There are a lot of there are malign actors or suspicious behavior that those actors don't want to be found. It's but with what we're seeing with greater capabilities up there, is it is getting harder to stay hidden in all domains and in all parts of the spectrum. with all these increased phenomenology, which is great if we can actually harness that data. But then as I think about it from a US perspective, it is also going to be harder for us to hide in the future and for us to have that element of surprise. So we need to be thinking about what that means for our forces and our capabilities as well. And then lastly, I'd hit US leadership in space and then foreign competition. With this technology proliferation, we are in a technical race. And so it is important for us to continue to push the edge, maintain leadership in space. It is our strategic advantage, and it also helps us build a strong space innovation base.
So I'm going to go to Ray and Guy. So you're chomping at the bit again, and we'll come back to you. Ray, I know you've been sort of holding it in. I think it's fascinating that we have traditionally, apropos this idea of getting to Guy's original point of too much data and overwhelming analysts. You're working at a company that starts as an analytics company, that starts as delivering the so what, and is now moving to space. And I don't know of another example of that. So what are your thoughts on this?
Yeah, I mean, so just for context, right, Tomorrowio, formerly ClimateCell, we are a software company. We are, focused on a very specific domain, which is weather and earth prediction. And because we've identified a really significant gap in observation and believe we can solve it from space, we're now developing a constellation of active radars that can see precipitation globally, that can map the oceans with altimetry, wave heights, etc. And so we come to this from the context of we have the models and we have the products and we actually do the analysis and we bring in the data sets that we believe are missing and nobody else is building, not a government organization or any of the private companies. I think the key here to make sure that data is not just getting lost or being built without a good purpose is you start with a problem that is well identified and the tool, and then you go back and data is missing, rather than starting with a sensor in space and then trying to figure out who cares about the data, who can use it, and how. And we think that's the only probably way of getting it to actually be used and impact. Thomas, you mentioned hurricanes, floods, all these stuff. These are models we run today and are going to dramatically be improved with these new types of observations.
Guy?
Wanted to go back to what Jennifer said a little bit and bring that forward. Validation and verification has got to be part of your timeline there in your processing block. And that's really crucial because if you get garbage in, you get garbage out. Keith knows it, the rest of you don't probably know, but I worked on that problem for the Air Force and the Navy, both on the tactical intelligence broadcast system. And then the integrated broadcast system, which both operated in the SCI world. With the rivet joint and the EP3E, we could bury our analysts, but we figured out a way to get around it, and we worked on it. So I'm convinced that it's feasible. But we used a term in those days called tactically useful time frame. And that's the term I would like to leave with you guys. What we're looking for is information in a tactically useful time frame. In some cases, their tactics are instantaneous, air combat. Others, you're talking a couple of hours. So you need to be able to turn that rheostat or that switch on and off to be able to manage that.
So we've touched a little bit, just as a natural consequence of our discussion so far, about the power of starting to bring some of these things together. So I'm wondering if some of you might share anecdotes. Certainly during my time in the military and as a government executive, trying to do intelligence integration, multi-int approaches to challenges was always sort of the holy grail. How would we do that? And we were having to fight against stovepipes, and we were having to fight against classification and policy and bureaucracy, and even the way in which we were funded. Put hurdles in the way of that. I have some hope that we're going to see in the commercial world incentives for companies to expose their data to each other, incentives for companies to come together. And I'm wondering if any of you could share some exemplars of where that's beginning to percolate or even where it's already working today.
I have One small example of that, we did a pilot a few years ago, and in fact in 2015. It doesn't matter who was involved, but we worked, what contractors were involved. We worked with the commercial SAR vendors, Cosmo, TerraSAR, RadarSat, all three of them. And we built a collection feasibility system for all of them so that a user didn't have to go talk to one vendor or another vendor. He could fees all three of them at the same time, pick the image he wants, and we had an electronic interface to the vendors. So when it would make a recommendation for your image. When you say, I want it, the vendor can tell you if he collected or not, and that took seconds, and you put your order in. So we were integrating 3 different commercial vendors with one tool for ordering and access. The users loved it.
Anyone else have anything to add on this one?
I do. Sure. We're seeing a lot of academic papers come out about the fusion. So I think when, we're seeing it in academia, and we'll see it more and more commercially and otherwise, but around vessels and fishing in disputed boundary areas and fisheries, where the combination of AIS, SAR, a VIIRS sensor, and EO has been used to track the numbers of, say, North Korean ships that are somewhere they're not supposed to be, or Chinese ships that are somewhere where they're not supposed to be, and tracking over time, because we can get daily imagery and bounce it off of these other sources, how impactful that illegal fishing is and projected out will be to food security and economies in those regions, et cetera. So that's very, very promising. And one example that we've seen of the integration of multiple sources.
Carrie, I think you might have some thoughts on this idea of bringing multiple sources together.
I did, Keith, and I loved what you outlined. This really is a challenge and an opportunity for the commercial space and data providers, and it's a differentiator for us. When you think about the government stovepipes that you exactly said earlier, we are not operating within those same bureaucratic stovepipes. GeoInt is one agency, Signals Intelligence is another agency. So we have an opportunity here to put pedal to metal. The example that came immediately to my mind in terms of vignettes was the Arctic. And we've done some great work detecting and geolocating RF signals, leveraging AIS, but also other emitters off vessels in the Arctic as the ice caps melt during the summer. And so we're seeing some amazing patterns of activity. And then working with some great commercial EO partners, we are able to tip and cue them, and they've been able to identify outposts and ports and other things that we had not been paying as much attention to. So it's a great example there of bringing all those elements to bear.
Thanks, Carrie. Brian, I know you had something to add.
Yeah, thank you. So very much agree with everyone else that having a multimodal approach is ideal, because really, if you look at all of the various kind of sensors that we're talking about, there's not one silver bullet. Starting out with very high resolution optical, there's the obvious challenge that there's clouds. Thinking about SAR, there's limitations today around coverage, and even if you get vessels detected, you can't necessarily identify vessels, detect or determine the activity they're engaged in. RF is promising, but not every vessel is going to be emitting a signal that can be detected. So because of that, no matter what, you need to have a multimodal approach to really have robust maritime domain awareness. And that's the tack that we're taking at Maxar. So one little vignette I can provide is we were monitoring kind of a diverse maritime region for illegal fishing. And we leveraged all of the major kind of commercial SAR constellations from our multi-sensor SAR vessel detection service. We utilized AIS for pattern of life analysis and to hone in on areas of interest, and then brought to bear our automated optical tipping and queuing capability. And with that, we were able to detect vessels that were fishing in areas that they shouldn't have been, and positively kind of identify the activities that they were engaged in to mask this illicit activity. Things like spoofing, transshipments with vessels that the reefer vessel transmitting via AIS, and the various trawlers operating dark, popping into areas they shouldn't have been fishing and popping out to mask that activity. So just one small example of how a multimodal approach, leveraging all of the positives of a variety of assets, can provide mission value in the IRU space. And a similar approach can provide value in others.
Thanks, Brian. I think it's a great way to lead into something that some people might want to touch on as part of this discussion. I know, Guy, you'll probably have some thoughts on this. As a military intelligence officer, it was always challenging to get my commanders to understand that the enemy got a vote, and that no matter how elegant their plan was, how a perfect school solution it was, that I was not, as an intelligence officer, able to ensure that the enemy would always do what we wanted them to do when we wanted them to do it. So through that lens, as we develop more and more capability, as we get this sort of new global transparency, and if we achieve the vision that I described a few minutes ago of multi-int collection, working all of this together, the adversaries are going to adapt. They have. Brian just mentioned some of those things. What are some of the ways that we are seeing adversaries, whether it's people who are working against embargoed shipping, who are doing illegal fishing, and other types of nefarious acts on the high seas? How are they reacting to our ability to increasingly have this view from above? Guy?
That's a great question. Of course, there's been AIS spoofing, but we have developed, and in fact, Orbcomm had the ability to do RF Doppler shift tracking on every emitter that they got. So from day one, we've known whether somebody's within 60 miles of where he said he was, and if they weren't, that immediately got flagged and moved on to other people. It is, my very first paper on this was called Collaboration is the Silver Bullet. I wrote it in late 2005, published it in 2006. We all need to work together, and they are in fact being very sophisticated, especially against the in sanctions, how to do that. And we need to work on that. But I'm hopeful. With Gary, you're going to like this. I wrote a paper that appeared in Spacewatch Global last year that I said the addition of RF geolocation systems, coupled with, it is not a replacement for satellite AIS. They are synergistic. And you marry those two together, and we're going to have and especially as you do RF fingerprinting, that is going to be a major counter. That's going to be a major step forward. So yeah, we have problems, but actually I'm an optimistic that we're going to solve this problem. We're going to solve this problem before any of us, except maybe Tom and I, retire. All the rest of you guys that have hair, right, Tom? But Gary, to be fair, there are now 4 companies out there building RF, and in fact, I thought Hawkeye 360 was the first, but Unseen Labs of France had a system up as well, and they've contacted me and said, no, we're first. I don't know who was really first, like satellite AIS, who really was first. I know that because I lived it, but there's a lot of people out there making claims.
Well, so, including the Chinese as well.
Yeah, I'm sure. Well, who knows? EOBN, the McDonnell Detweiler has had EOBN for years, and starting in 2008, they've invited everybody, and both China showed up and Russia showed up to the first one I went to. EOBN, Earth Observation Business Network. They invited everybody that had a capability to monitor the Earth, and nobody thought about the maritime world, and that's why they invited me to come speak, because since then I now know what it's like to be a rock star. For about 2 days there, when I said, hey guys, you can make money here. And it's not because I look like Brad Pitt, although I'm sure you see the resemblance. It's because I look like a dollar sign or a euro sign. So yeah, we're going to solve this problem. And RF radio fingerprinting is the key to it. Is when we can figure out how to do that and sell that, and get it to somebody in a tactically useful time frame, as Tom said. You marry that with SAR, with AIS, add in some imaging when you have the opportunity, and add in the Jennifer, as you said, the continuous following. I had a conversation with your bosses, the founders of Planet, 5 years ago, 6 years ago, and said you need to do just exactly that. I'm glad to see you are doing that today.
Thanks, Guy. Do others have anything to add about this idea of how they're seeing Ray? Do you have how you're seeing people react to the openness that's starting to occur?
Yeah, I think, in the context of weather, it's not such a, new thing, right? Of countries collaborating, and, the Navy is using data from Chinese satellites, right? So there's a lot of collaboration happening in weather and climate because we're not looking at, man-made stuff. We're looking at the atmosphere together, and we all benefit from joining forces on it. I think it's just going to become stronger, and we will see many more, and eventually the majority of the valuable information coming from commercial operators rather than government-owned satellites. I think, the key, and what we're doing at Tomorrow is really identifying what are the biggest observational gaps we have today to improve our modeling skills, our ability to inform, users on hurricanes or any type of other weather phenomena, and then solving backwards from these gaps to what instruments can deliver the answer in the fastest and cheapest way. That's what we're doing.
Brian, I think you had something to add on this.
Yeah, thank you. I just wanted to jump in and talk a little bit about the vessel fingerprinting idea that Guy brought up. That's something that we're also driving towards on the optical side. So given advances in facial recognition kind of detection, we're taking those and applying those to our satellite imagery, where we've created a database of images, optical images of vessels tied to unique identifiers. In most cases, MIMSIs, and other instances, kind of a proprietary system. And with that, we're utilizing that data set to create training data so that we can provide probabilistic matches, and ideally matches of dark vessels as we detect them. So as opposed to just providing an image of a vessel, we've been unable to correlate to AIS, actually saying it's XYZ vessel, or 50% chance it's this vessel, potentially it's its sister ship. And I think that identification is really the future. Whether that's occurring, Guy, as you've mentioned, in RF, which I think is promising, given the potential to do so off of X-band radar and other radars, or on the optical side, as we're chasing after it currently.
I appreciate that, Brian. Guy, you have something to add?
Yeah, I do. I just got contacted by a Polish company last month now called Satim. They're doing the same thing. In fact, I talked to McDonald Detweiler about that last week, and they'd never seen anything like that. Also talked to Space Eyes. They haven't seen anything like that. Talked to the Office of Naval Intelligence. It's all, that technology is coming, and it's good. But by the way, why I keep coming back to fingerprinting is in 1968, I learned how to use a WLR-1 in Vietnam. We could not fingerprint at that time. When I came back in 72, after having gone to a bunch of schools, we could. And so I know that we can fingerprint radars. If we can manually fingerprint radars in 72, we ought to be able to do it today with automation.
Keith.
Carrie?
So we like to call it unique signal recognition, but guys, he's bringing up a great point. Bringing up a great point as well, and it is a potential game changer. But it is not in isolation. So back to Brian's point, it's bringing together all of these different sources, so that unique signal recognition with other, whether it's SAR or electro-optical imagery, but also publicly available information. There is just immense information out, not just social media, but financial, vessel registries, that if you can pull that all together, get it to a common point or a common reference frame, that is incredibly powerful. And then just the other thing I want to reiterate is, with all of these capabilities, it is getting increasingly harder to stay hidden in all domains and all parts of the spectrum. And I think that's really the value proposition of what Multisource provides.
So Tom, I know you have something to say. I want to react, Carrie, to something you said there. I've often said, like, if you want to know where a capital vessel is on the face of the earth, ask Lloyd's of London, right? Those who are insuring those vessels know exactly where those vessels are all the time, sometimes even better than the owners of those vessels, because they have a certain interest in them. But Tom, please go ahead.
I just wanted to acknowledge, you asked what are other actors doing to suppress us. I want to acknowledge what the US government has done to enable this. They're doing some things which I thought I'd never see. We've got SIGINT satellites, right? That's Hawkeye 360 with these licenses, and he's talking about fingerprinting, RF. And we've got commercial licenses in the United States to have 1200 megahertz bandwidth for a commercial SAR sensor. I thought I never would see that. And I think the United States government has realized you can't suppress technology in the information revolution, and we have to allow US companies to do this. Otherwise, other people are going to be able to do it, and we won't be able to. So that matters too.
So as we are wont to do, because we are the very best in the world at ethnocentrism, right, in the United States. Carrie, you touched on recognizing Chinese capability. What other things do we need to be thinking about, even as we think about our ability to have freedom of navigation on the seas, our ability to operate unimpeded? What are other nations able to see? I think there's a little bit that we fell prey at the end of the Cold War, that somehow we could operate with impunity, and that we've been in theaters where we had air superiority immediately and felt that nobody could see us from above. And I think that the global nature of the advances in remote sensing across the board have really changed the calculus. And I'd be interested in anybody's thoughts on what the impact to US operations is as a result of the fact that, oh, by the way, we aren't the only ones with these capabilities. Carrie?
You said my name, so I'll take a first stab at that. It should be a wake-up call to us and to our forces, our intelligence collectors around the world, that you can be seen now. It is not as easy to hide. We no longer will potentially have that element of surprise, maybe, but it will be harder. And then, as we think about the operational security of our forces and capabilities, what we can do to others, they can potentially do to us as well. And this all goes back to that proliferation of technology. But then, as I look at what is the U.S. government's role? We're not asking them to be anchor tenants to bail us, out. We're leveraging private capital to go forward. But the government needs to show a leadership role in terms of adopting, integrating this technology, leveraging the data and services and the multi-intelligence products that are coming out of all of these companies. But then there's also a global role. And I think, Guy, you mentioned it at the outset here, is there is so much potential for us not just to look within US government, US commercial, but also with allies and partners. And the beauty of what many of us here are doing is we are doing things unclassified that can be shareable and leveraged by our allies and partners, which, in many cases, those US government systems cannot. So this is a great pathway for greater cooperation with partners as well.
Ray, you've had a unique opportunity to operate in a different environment, in a more congested and contested part of the world, where you were in a very different set of circumstances. So I think your perspective would be valuable here on this one.
Yeah, and just for context, I'm an Israeli Air Force veteran, so coming from that region, I think the baseline assumption going forward should be that the entry ticket price to become a space player and to own sensors globally has reduced by, I think, 2 orders of magnitude, more or less, which means that we're going to see all sorts of players that have previously not have access to space now in space, and that includes countries and companies from different geographies under different regulations or lack thereof. And so the assumption should be that, and the sensors and all these capabilities are widespread by now. I think the advantage we have in the US on these technologies exists still, but it is not going to stay as big as it was for much longer, right? So we need to just live with these assumptions and plan accordingly, and that's on all fronts, defense and others, I think there's also a huge opportunity here for collaboration, right? And that opens up tremendous opportunity for multiple types of players, again, working together in the context of defense and kind of more of the civil applications, to bring together all these capabilities and build really amazing stuff that, otherwise would have stayed as an idea.
Brian, in the event, I didn't want to miss you on this if you had something you wanted to add.
No, but I will briefly echo the importance point that Carrie brought up about just having shareable information for coalition partners. And on top of that, having just complementary data sets that can augment kind of proprietary governmental capabilities.
So as we come to the end of our time here, what I'm going to ask each of you to do is wrap up with some sort of overarching perspective, both thinking back to your earlier presentations, thinking about our conversation today, and please, during the course of beginning to kind of pull things together at the end, if you want to address what new phenomenologies. We've talked about SAR, we've talked about electro-optical, we've talked about RF, hyperspectral snuck its way into the discussion briefly, but what types of things, both quality, quantity, phenomenology, are on the horizon, if you will, that we should be thinking about and talking about as we look forward. So as you wrap it all up, please feel free to address that one as well. Tom?
Okay, so SAR guy, and we've seen there's going to be a proliferation of SAR sensors that are getting developed now internationally and in the United States. It's going to get mixed with AIS data, passive RF data, optical data to do automated ship detection, find dark vessels. I'd like to talk about what I think is going to become a killer app for commercial SAR, and I like to call it intelligent site monitoring via SAR genetic stack. So imagine you want to watch a place. This is maritime, maybe a port, a glacier, an ice field, an erupting volcano, an airfield. Suppose I can look at that place every day. Well, that has to be SAR because it can get you a picture. But I can look at that now. I'm going to be able to every day from nearly the same place in space. Well, if I can do that, and every image is an exact match of every other image. I like to say they all have the same DNA. They have the same geometry, they have the same radiance, and they have the same phase. And phase can be measured from SAR to with a small fraction of a single wavelength, even though it might be 700 kilometers away. So that is a change detection richness in which we'll be able to see what's happening, not just did a change happen, but what happened. This thing changed, and here's how it changed. And I'm not quite sure, so go take a better looking image from Maxar to see it. So I think we're going to have intelligent site monitoring from SAR in the near future at a cadence that's never before existed.
So speaking of cadence, Jen, might you have something to add here?
Certainly. Thank you, Keith. I think we will see, obviously in the future, an increase in cadence and, or what we call revisit rate, and also increasing resolution. Another direction, though, that I want to mention about the future is we are in a kind of a consortium, public-private partnership that was announced last week to launch hyperspectral satellites that can detect methane. I think we'll see more and more of that sort of thing. It's a beautiful public-private partnership, I think a great model. And we're excited to see, bringing it relevant to this conversation, what that might do over the oceans, both for national security, global security, and biodiversity. I also want to say, I think in conclusion for me, throughout the conversation, we have talked about the shift from, wholly governmental led space or remote sensing and the like, to the shift in the proliferation from commercial entities. And I think Carrie mentioned a ton of investment. Everybody's seen in the news how much investment's going into space companies right now. Carrie also had said we're not asking the US government to be anchor tenants. But I do think that there is an issue that has to be addressed. It's kind of the elephant in the room, is that the US government does have a lot of market influence, a lot of market power and leverage, and spends a lot. And so with that shift, as a community, as a country, as a global society, we do need to ask ourselves, what is the US government's role in that, in ensuring that we're kind of bending towards truth and transparency and creating both continuing US leadership in space, and what benefit that commercial US leadership in space has to the US economy and US's role in the world economy. So that's a very important element to us, and I think to all of us here, given our roles in the industry.
So Ray, you're a little bit of an outlier with this work with the weather. Many of us just sort of believe that the weather is just something that happens to us. I think you're proposing that we can be a little smarter about it, and that with something like weather intelligence, we're not just victims of the weather, but we're managing and actually can use it to our advantage. So what are your thoughts on where we're headed into the future and wrapping up?
Yeah, 100%. I think what we're going to see in the context of weather, and I think more broadly Earth prediction, right? Every Earth system is, we're going to see dramatic improvements in our monitoring and therefore modeling and forecasting capabilities. We're building that. But the second piece is, okay, we know what's going to happen. That's great. But what does that mean for us, right? And us can be anything from a military operator to a construction site manager to an airline to a farmer in Africa. Each of them is impacted in a different way and needs to consider and think about different elements of, the weather that impact their specific job flows. I think what the future holds in this case, and what we're extremely excited about, is the ability to really using software, and for saying AI and ML, but that's the truth, be able to provide each and every one of these, thousands of different use cases and users really the answer they need, because there is so much information, as you said before, right? Like weather is consisted of hundreds of different variables, geophysical parameters and time frames, etc. What do I care about as a farmer? What do I care about as a, emergency management worker working for FEMA or whatnot? And the ability to just take all this massive amount of information, improve the forecasting to a point where we can just say, here's what you need to do. You need to evacuate those 2 streets tomorrow between 2 to 5 p.m. That's all you need to know. That's a radical change, and that's where we're heading.
Thanks, Ray. Brian, so here we sit with, on the precipice of Legion coming online. What's your view of the future as we walk off here?
Thanks. So I first want to start by going back to some of the comments that Tom made and a number of the other panelists just around the proliferation of sensors. That's absolutely going to be a game changer here in the near term, where detection is going to become just that much more of a commodity. And it's going to be requisite for commercial providers to be responsive in generating data, providing data in low latencies in order to kind of rise above the rest. I think, though, that beyond detection, we're going to be moving to a paradigm where we're forced to do more to provide identification, or as Guy was terming it, fingerprinting of vessels. And even beyond fingerprinting of an individual vessels, fingerprinting vessel activity. On the Legion point, with our new constellation coming up, we'll have intraday revisit of up to 15 times, allowing for us to play in the maritime space in a truly unique way with industry-leading 30-centimeter resolution, allowing for us to provide more opportunities to fingerprint, identify vessels, identify vessel activity, and be a part of a true multimodal approach via automated tipping and queuing. Last thing I want to bring up for the future is I think that there's also potential in more the 5 to 10 year type horizon to partner more closely across modalities, to launch them in orbit so that there's close proximity, and to allow for things like onboard tipping based off of onboard vessel detection type capabilities, further reducing kind of latencies and providing even that much more complementary benefit of the various modalities that are in orbit.
I appreciate that. Carrie, Coming from sort of the cool new kid on the block with RF from the commercial world, what's your perspective as we're in the home stretch here?
Super, thanks, Keith. So first, if I can start with an asterisk and say that, so RF GeoInt, we are doing geolocation and mapping of signals. We are not doing internals. So from that perspective for SIGINT, we're not doing internals. And we have very clear privacy policy that we abide by. Hey, I will say I am really excited about the trailblazing that Hawkeye is doing. We are creating a new RF geospatial data layer for deeper insights on ocean and maritime awareness. And as Jen said, which I really liked, it's increasing transparency for the globe. Shareability, it is new, us and my colleagues on the panel here, we are creating new pathways for cooperation with allies and partners. We're creating greater diversity in architectures, not just architectures on orbit, but those distribution pathways to a variety of users across the globe. And speed. I come from a community where we measure speed in years. My fellow panelists here, we talk months, and it's mind-boggling and it's awesome. So when you think of the technology refresh opportunities that are there, as well as just expanding the STEM bench of talent in American companies, I just think it is awesome. And I agree, I'll echo Jen's point here, but for all of this to happen, for us all to be successful, we do need US government leadership in commercial space, adoption, acquisition models, regulatory environment, and then the policies that enable us to export to our allies and partners.
So Guy, all of us are here today talking about this topic when you were doing it before anybody was really thinking about it on the level that you were thinking about using space to be able to get at this. So I think it's only appropriate that you're sort of our cleanup hitter today. So very interested in how you close this out.
Well, collaboration is in fact the most important thing. And by collaboration, I mean sensors wise and politically. However, let's talk about where we're going in the future. What about the main threat I see out there that we don't have a counter for yet is submarines. I believe that we're going to figure out a way to acoustically detect submarines and maybe other sensors as well, pass it up to a satellite so that we're going to have a short link. So for you guys out there in industry, go talk to your boss about building that. I know some people are looking at it already, but how good we are going to be. It is fascinating that we are where we are. By the way, I use the term tidal wave, not an explosion. Explosions in space are not good. Neither are tidal waves, but in the ocean, we're looking at tidal waves for us maritime people. And that's what we're seeing. And that tidal wave, when I came up with the idea of satellite AIS, almost immediately 10 different organizations from 6 different nations, Canada, Norway, Germany, Italy, France, and Japan all came to see me and wanted to sell me their wares and to collaborate with me. And that was in summer of 2004. And I thought, wow. And I had been a military person up until that point. And I was looking just at the security aspects of it. But there's so many other things we can do for environmental protection, disaster protection. It's all there. And so we do need to do it at the unclass world. And by the way, I don't know if you were aware of this, but the NSA tried to classify, after I had been talking about it with the approval of the front office of NSA, because they were ex-students of mine at that point, they tried to talk about 2 years after I've been selling the idea of satellite AIS, they tried to make it SCI. And that really concerned me because it was going to kill my program. But the Secretary of Defense decided that it needed to stay in the unclass world. So it's there today. And it's the start. The geolocation that's given you in satellite AIS and the ID is the basis. We can do this all the way across the world because there are people operating today in this program everywhere. Africa, Asia, South America. I'm sitting in Lima, Peru right now. And good friends of mine ran the surveillance system both in Chile and Peru and Brazil to detect ships from space. And they're all a big part of it. They want to know where we're going. It's all there. It is going to be an open source. I'm really sorry that we did not enact the implementation plan of task number 1 of our national space system, because we did need international leadership. They were expecting us to step out, and we didn't. So, and in fact, I wrote my congressman about it a couple months ago saying, it's never done. We need to do it.
All right, Guy, thanks so much. Thanks to all of you. When I think about the experience and talent and everything that this panel brings together, it's really been a pleasure to speak with you. I appreciate the opportunity. I appreciate your time on behalf of AGS, and thanks very much.
What a fascinating discussion. It's rare to get such a collection of remote sensing experts all in one place to discuss the future of how satellite remote sensing will help us secure our oceans in the decades to come. But now, Keith, it's just you and me. As an expert in this subject in your own right, as a strategic advisor to both government and to industry, and as the person, many people may not know this, a person who actually tasked America's spy satellites when you were in the chair sitting in government, what strikes you as the most disruptive change that is either going on now or that you think is right around the corner in terms of how we use space remote sensing to secure our oceans?
Well, I appreciate your kind words, Chris, and that really was a fun panel to be able to moderate, and I appreciate that as well. I kind of touched on it in one of the questions. I asked a leading question to our witnesses. I really think the magic is going to happen in the integration of all these phenomenologies, right? So when we have electro-optical, we've had that for some time. We're bringing on synthetic aperture radar. We have the arrival of RF from space. We're going to be having hyperspectral LiDAR, helping in the littoral, now moving from airborne to space. As we have always pursued on the government side, the rich data and information that arises from the ability to put all these things together and to complete the picture. And now that we have the processing tools to do it, we have the sophisticated software, we have the machine learning that leads to artificial intelligence. We really are on the precipice of doing things that we've thought about for a long time, that we've tried to fight internal to the government, as I mentioned in my question during the panel, through all sorts of bureaucratic obstacles to get to it. Well, now, while there are certainly other challenges presented by this happening in the commercial world, many of those internal to the government obstacles don't exist outside. And so if we are able to create incentives, if we are able to get it so that companies will sign NDAs, will expose their data to one another, will bring in the companies that are working solely on powerful data analytics applications, the intersection of all that will lead to a global transparency that far exceeds anything I think that we have anticipated.
Great. So for the next generation of national security leaders, whether they're currently in high school or maybe just joined the armed forces, maybe they're actually somebody who's getting ready to take the hot seat in the current administration. What would you encourage them to learn about satellite remote sensing, and maybe how would you suggest they go about educating themselves?
Well, as you know about my background, Chris, as a liberal arts major, as a political science major, who ended up in an extremely technical field, because thanks to the Army, they kind of saw that liberal arts degree and assigned me to one of the most technically complex units in the Army. And as I like to say, the Army will sort of toss you in the pool and suggest to you that it's a great time to learn how to swim. I would say that it is the intersection of the quantitative and the qualitative. That's where we are right now. My youngest is a freshman in college. She's studying international relations. I've asked her, and I know she's going to do it, to do a minor that is more quantitative, that she is literate in data science. I don't think she needs to be a coder, but I think she needs to understand a language, one of the current coding languages, just so that she's had the experience of thinking that way. I think in order to be an effective professional in the national security realm as it relates to remote sensing and associated disciplines, it's absolutely being able to, if you're an engineer, then you've got to have some understanding of the mission applications of the things you're building. What are the operational implications, the operational needs that are being filled by the technology you're creating? Conversely, if you're someone who is an analyst and you might be an area analyst in the Indian Ocean, having the ability to understand the technologies, to go into the kit bag of all the things that are available to you to give you quantitative things that allow you to measure and add to your body of knowledge in that region. You are a better analyst if you have some understanding. So again, it's that there's got to be this mix of the qualitative and quantitative, and it's not comfortable. It's not easy. I have endeavored to avoid. I have not taken a math course since junior year of high school and managed to make it all the way, through a graduate program. So it's not, don't do as I did, do as I say. Get into an uncomfortable space for you. Get into fill in that other side so that you are the best professional you can be, and you are prepared to operate in the current and emerging environment.
Thanks for that. I know everybody coming up is always searching for wisdom and no better source. Last question. What are your hopes for the future for satellite remote sensing, right? You've lived through a couple decades of it. You're in the midst of the action right now, and you have a sense of the trajectory of where it's going. What are your hopes for the future of satellite remote sensing, particularly as it relates to our ability to secure our oceans? 70% of our globe is covered by these oceans.
Yeah, look, I'm gonna get a little sappy here, Chris. I've got 5 children, and getting ready to, the first one's getting ready to get married here this summer. I'd like there to be oceans thriving and filled with flora and fauna in the future. And I'd like our Earth ecosystem to be around for a long time. And we are clearly experiencing a significant change in our planet. And so here we have, at the very moment this climate change, this drastic climate change is underway, we have never had a better ability to measure it, to understand it in granular detail. Right? We had a person on the panel who was talking about precision weather, and we've got other people who are able to characterize changes in glaciers with electro-optical and subsidence with synthetic aperture radar. And we can get at food security by understanding violations of protected fishing areas, and we can get at restricting bad actors by being able to hold sanctions and hold people at risk who are violating sanctions. So we have this wonderful opportunity at hand to understand the system of systems that is our planet, to protect and defend our oceans, and to stop nefarious, man-made, man-caused activities that harm international security and harm harm our climate and harm our Earth systems. So we've got a great opportunity at hand. We must not squander it.
Wonderful. Thanks, Keith. Thanks for imparting your wisdom, your insights, and your experience with us today. Until next time.
Thanks so much, Chris. I appreciate the opportunity.
It's easy to think that we have so many eyes in the sky that no maritime threat could escape our view. Some call this geo-ubiquity. Others call it persistent surveillance. And while this is our future, it is not true today. Just blink your eyes and everything in our ocean changes. We are challenged by both its vastness and its noise. The new diversity of commercial remote sensing satellites is a powerful tool that's helped supercharge what is actually still an arduous process of analysis and sense making. I look forward to the day when artificial intelligence and machine learning will help to take some of that burden off the analyst, elevate them so that they can literally and figuratively see further and understand more. about all of the threats and opportunities that exist in the majority of our planet that is covered in oceans. Today, we have the suspense and intrigue of great power competition, the heartbreaking natural disasters, and human-generated perilous seaborne migrations, each of which demand our attention and each of which demand our assistance. We find ourselves thirsty for more and better satellite remote sensing of our oceans. This forces us to continuously monitor and reassess what is going on in different ocean geographies. Someday, we will achieve a sort of persistence when it comes to understanding our oceans, but this persistence will only be achieved with the powerful AI contributions of those observational platforms that we have on orbit. All to say, I could not be more excited about the opportunity that we have to create a better, more open, more just planet for all.
We hope that from today's discussion, you now have a deeper sense of the art of the possible and the power of space-based remote sensing for helping us secure our world's oceans. After all, our nation and our global society depends on our oceans being safe, secure, and sustainable, off into the distant future. To learn more about the future of our world ocean, go to geography2050.org/oceans for hours of fascinating content from thinkers, innovators, and leaders from around the world. Until next time.